A very warm good afternoon to all of you. Offshore platforms are classified based on the geometry into fixed, compliant, and floating platforms. Today we'll be seeing the offshore fixed type platform, and in that, the features of the jacket platform in detail. What we see in this slide are jacket platforms, and which is in the Western Offshore and is maintained by ONGC. And this is one of the famous ones in the Western Offshore, the Mumbai High, which is the Southern Basin. This field was discovered in the year 1976, and it's approximately 80 kilometers from the Maharashtra coast towards the Arabian Sea. The water depth would be approximately 50 to 70 meters, and it's primarily a natural gas field. And the gas that is produced in these fields are sent to the Hazira processing plant. The Southern Basin field hit a peak of about 29 million standard cubic feet per day in the year 2011. We can see that the jacket platform could be a single unit with all the facilities together, or it could be in a spread arrangement like this, wherein you have the production facilities, the living quarters, the flare boom, and other booster arrangements. Now here they are all in a single unit where you have the drilling, production, and the cellar decks. We can also see several conductor pipes through which the gas is produced, and it is sent out through an export pipeline. Now this pipeline is connected to the Hazira processing plant, which is also maintained by the Oil and Natural Gas Corporation of India. We have seen in the previous slide the images of the jacket platforms in India. This is the sketch of how a jacket platform would look like. What we see in images are just the top portion of the jacket platform. It is like a tip of the iceberg. The most of the portion is underwater. So here we can see the jacket substructure and the module supporting frame on which the top sides are connected, and it is the piles that is actually able to support the jacket platform from the environmental loads of wind, wave, current, and also helping the jacket platform not to overturn because of these loads being acted upon. We can see a drilling derrick, we can see the drilling module and the production module here, and the heli deck. There is a flare stack at a distance from the living quarters. It is always like that because you do not want the heat radiation to come towards the living quarters, and in case of any emergency you have the survival craft. There is a revolving crane, and one more interesting thing that we can see is the jacket platform more or less acts like a template. Sometimes this jacket is also referred to as a template because we can drive the piles through these pile guides and pile sleeves. Now, once we are driving the pile in this particular pile guide, it will orient only in this direction. It will not get misoriented. In a way, it will help that there is no clashing between the piles. Now, if I am having pile guides only in this location, there is a chance that the piles may get intersected somewhere down. So in order to prevent that, we are having pile guides, okay, and a group of piles are called as bottles. Now we can see that there are two rail-like structures here that is called the launch runners. These is used for actually transporting the jacket from the yard to the barge. So there will be a rail-like structure on which the jacket would be slided to the barge. So for that we need this launching runners, and we have the drilling conductors here, and once produced, once we have the gas or oil produced, after going through the separators, it will actually come out through the export riser. There's an export riser here which actually connects to the processing facility through pipelines. The term jacket actually refers to an enclosure because the jacket supports and protects the well conductors as well as the risers. This jacket platform has a pyramid shape which is truncated on the top, wherein the top sides or the deck rests. The steel members are tubular in nature, in geometry, because it creates less resistance to the waves and currents, because the tubular shape offers such a feature, unlike some other geometry like a square geometry wherein the force would be impacted more. This tubular members results in reducing the amount of steel and in turn lesser weight and lesser cost. The drilling production and cellar deck are on the superstructure. Also, the platform, as we have seen before, is position restrained from the incoming loads by the use of piles. The code that is used for designing a jacket platform is American Petroleum Institute recommended practice 2A. We can see that combination of engineers, right from structural, ocean, mechanical, petroleum and chemical engineers are required to design it right from the design phase to the commissioning and installation phase. We can see that the superstructure mainly comprises of 3 decks, that is the drilling, production and the cellar deck. Having said that there are 3 decks of drilling, production and cellar, we'll just quickly run through what are the components in these decks. The drilling deck primarily consists of the derrick, the mud pump package, flare boom, helipad, living quarters. It has a lift gas compression unit which needs to be supported by the inlet and outlet dehydration filter. In between them we have the glycol contactor as well as the glycol regenerator. This is done mainly to for dehydration, removal of water from the gas. And we can see that in the production deck we have the wellhead, the production manifold mainly, and as well as the separators. So once the produced hydrocarbon comes to the separator, the crude oil is subjected to the crude oil heater, followed by the electrostatic heater wherein the gas is flared, and then it moves to the crude oil pipeline pump, the crude oil cooler, and then finally to the export pipeline wherein it goes to the processing facility. We are also having components of water injection wherein we need a cooling water cooler, deaerator and the water injection pump. So these are basically the components that are housed in the 3 decks. The jacket platform is supported by a combination of trusses and columns. Now these, what you see at the ends, are primarily the 8 columns, and they are interconnected using something called as braces. Now, there are several types of bracing. It could be a horizontal bracing, it could be a diagonal bracing, it could be an X type bracing. You can see all these bracing types can be seen in the jacket structure being shown here. Now what are these for? Now we have to withstand the loads that are acting. Primarily the weight of the decks, that is the production, drilling and the cellar deck, which is referred to as the dead load, needs to be withstood, as well as the live loads. that are acted upon during the drilling process, and also the wave, wind, and the current loads. Now these loads are to be taken by the jacket and also the piles to which it is connected to the seabed to prevent it from the overturning movement. Okay, so these are the basic loads acted upon and the type of bracings that are being used. The biggest platform built in this geometry is the Bullwinkle platform in the Gulf of Mexico, with a total height of 529 meters and the weight of 77,000 tons. It produced about 59,000 barrels of oil per day, generating a revenue of 7 million US dollars. The construction cost was approximately 500 million US dollars. See, such a big platform, we are only able to see the tip of the platform. You want to see how the platform was being transported using a barge. You can see the actual structure. See how big it is. It is to be ensured that there is no deformation in any of these parts right from installation to commissioning. Say if there is any small plastic deformation in any of the pile guides, it can cause a misorientation and it will cause difficulty in the commissioning of the platform. So one needs to be so careful in the entire designing process for these platforms.